Hey, it's Pete. I'm here in New York, and today we're talking to Dag from Tapad. Dag's the founder and VP of Engineering. Thanks for being with us, Dag.
Thank you for coming.
So first of all, tell us a little bit at a high level, what is Tapad? What do you guys do?
So Tapad is a cross-platform, or I'd say multi-platform advertising company. We're what's called a demand-side platform. So our customers are the actual advertisers, and they buy advertising through us. We're in what's called the real-time bidded space. This means that we are constantly processing a lot of potential buy opportunities for ads, and we figure out in real time if we want to buy an ad and how much we're willing to pay for it, and then we figure out which ad or which banner or whatever you want to place there, and we do all this in real time. So it's a low latency, high throughput kind of business.
Okay. And tell me about the mobile aspect of your business.
So the mobile aspect is there have been mobile ad networks for quite some time, which are fairly, maybe not unsophisticated, but the mobile space has been lagging behind in terms of the progress that's been made in the online display space over the past few years. So especially on the side of real-time bidding. So we're trying to bring some of the more sophisticated use cases or uses of advertising technology to the mobile space.
Okay.
And we also allow customers to do cross-platform targeting, so you don't have to go to one provider to buy mobile advertising and to another one to get the online display. We're more of a one-stop shop.
I see.
And we do interesting things based on what people are doing on their mobiles. We can use that for targeting them on their desktops and vice versa, which has started to resonate really well with a lot of advertisers.
Okay. So technically, this means that because you guys are doing real-time bidding, there's a high volume, low latency requirement for your architecture. Is that correct?
Yeah. So basically, how it works is that whenever an app or a mobile web page or a traditional web page is being served, and there can be multiple ad units on that page or in that app, as the page is being rendered or as the application loads pretty much, we have to make a decision, or the whole network or the whole system has to make a decision, which includes quite a few jumps from, let's say, a mobile website. They call an ad exchange. The ad exchange calls us and a number of other vendors or demand-side platforms, and we all look at the data that we're getting. We compare that to the campaigns we're running, and we return basically a bid saying, okay, this impression is worth this much money to us. And all this has to happen before the user actually notices, because you don't want to show a page with a lot of white blanks on it, or like some sort of spinner, a loading thing. So the requirements are pretty strong. You have to respond within typically 60 milliseconds, and this includes network round-trip time. So it's the total processing time is very, very short.
Okay.
I mean, there are companies that have higher volumes than we do in the online display space, but we are currently processing about 25,000 requests per second on our servers.
And that's one reason I heard that you guys actually made an interesting decision to move off the cloud. Can you talk to us a little bit about that?
Yeah, I mean, we started out as a lot of companies on Amazon Cloud, and so the EC2 Cloud is excellent to get started, and it makes it very cheap to start running a service. Generally, though, running on a public cloud where you have a lot of shared infrastructure makes it hard for you to really find the hotspots and find what's causing jitter in your performance. So when you're running on virtualized hardware, you're running on shared network infrastructure, you're running on typically shared storage. And we're a JVM shop, so we also have garbage collectors which add to the whole mix. If you have too many moving parts, it makes it really hard to pinpoint where are our main sources of performance issues. Are they something that we control, or are they in the actual infrastructure? And we realized that in many cases this was actually in the infrastructure. I'm sure you can cope with that in many ways, but to us, being able to respond on a timely basis every single time is very important. So to us, the average response time doesn't really matter much. What matters to us is how many requests or how many incoming requests are not handled within that very stringent time that we have to process it. And if we're losing 10% of all requests because we're having a very high latency on our 90th percentile, that is actually, it might be 10% lost business for us, because we cherry pick every single request, and if we miss 1 out of 10, that's $1 out of $10 basically.
Okay.
The other factor is actually in terms of cost. We see that we can, when you start scaling up a little bit, start buying more specialized hardware, more expensive hardware, then very quickly you get a better performance ratio with your own cloud. And we also have some hardware that you don't even get in the cloud at all. Like we're using solid state disks for our key value stores. And we also have some, on the analytics side, we have some very, very high memory type hardware. And memory, RAM is something that's often very expensive in the clouds.